A coreference resolution is a task in which we try to identify what are the different phrases or words in the input document that refer to the same thing. Okay, now the same thing, it can be like some entity and so on. And we'll look at some examples of that. And when we go through those examples, it will be clear that understanding co-references actually requires a good understanding of the semantics and the organization of the input text. So it is one of the tasks which, as I said, it is one of the tasks which requires deeper understanding of the input. And that's why whenever people come up with newer models for, say, different embeddings or different foundational models, one of the tasks in which they show the method's performance is some co-reference resolution task. So with this brief intro, let me now go to the exact topic. Okay, so if you look at the examples on the right, so the first example on the right, let me turn on the pointer. So it says the HP Pavilion laptop has a lightning fast speed. The laptop works great. When I first got this computer, it really rocked. Okay, now if you look at the words or phrases which are marked in rectangles in boxes, you'll be able to see that they all refer to that HP Pavilion laptop, right? So it really rocked. What is the thing that really rocked? This computer. And what is this computer? This laptop. What is this laptop? This HP Pavilion laptop. So all of them are actually co-references. They refer to the same entity. Now, if you look at the next one, I voted for Nader because he was the most aligned with my values, she said. Now here also it is, I mean, for us, for human beings, it is easy to identify that Nader and he, these two are co-references, and she, my, I, these are again co-references. So this is essentially what is co-reference. So I mean, there can be two different tasks here. One could be like given this phrase and this phrase, you'll have to identify whether they're co-references or not. Okay, then this is a positive example. A negative example could be like the HP Pavilion laptop and I. Is this a co-reference? Here the answer will be no. So in one co-reference resolution task, you can be, or one form of co-reference resolution task, your input could be a pair of phrases from the input. And also this entire thing also will also be given to you. So given an input sentence or passage and a pair of phrases from that, you need to output whether they are co-references or not. So this is one task. Another task could be like you are only given this entire sentence or phrase and you have not been given any two pairs, but your task is to identify all the co-references here. So in this case, there will be one co-reference chain, which will have these four phrases like it, this computer, the laptop, the HP Pavilion laptop. And in the case of the second one, there will be two different co-reference chains. The first chain will be, one of the chains will be he and Nader, and the other chain will be she, my, and I. So these are typically the two most common co-reference resolution tasks, and there are quite a few other related tasks also that we will see in a minute, or not in a minute, but after some time. Okay, now after we go through these examples and some example tasks, so let us go to the some and talk about some specific terminology which is offered, which is commonly used in this co-reference resolution discussion. So one is reference. I mean, what do we mean by reference? The process by which the speakers use expressions to denote an entity. Okay, so these are all references as such. And the referring expressions will be expressions which are used to perform reference. So for example, here we are seeing the word it. Now this is an expression which indicates some reference, indicating that something is referring. So it is a referring expression. And for any referring expression or with any referring expression, there are two different things. One is the referent, okay, which is the entity that is being referred to, and the other one is referring expression, which is this one. So like head and tail of this reference. And co-reference is referring expressions that are used to refer to the same entity. So these four together will be a co-reference. Now this co-reference can be a set, or it can be it's typically a set. Okay. Then anaphora means reference to a previously introduced entity. We'll have some examples of anaphora. So here, this is the referring expression and this is the referred expression, right? So what we see is that the referring expression comes afterwards and the expression to which it refers, that has come before. Okay, so for the word he, this word nader is, so this is an anaphora. So he is referring to something which has been spoken about earlier. So this is an anaphora. So there's some more examples we will give here. Yes, Samir, is there a question?
Sir, just what you mentioned, sir, in that nadir is, I thought it is referent. Nadir.
Yes, this is referent and this is a referring expression.
So
You're
anaphora, okay. So nadir is both referent as well as an anaphora.
yes, true.
Okay, okay.
So if the referent is coming before the referring expression, it is anaphora. If it is coming after, it is called cataphora. We'll have some more examples of that nature.
So in
Yes.
the co-reference, so basically the referring expression plus referent make the co-reference. Can we say that, or like, because co-reference are also the laptop, this computer, it, right?
Yeah. So when we say the identify co-references, it will give you this complete sets. So inside that set, all these four will be included.
Including the referent.
Yes.
Yeah.
Yes.
Okay. Yeah. Thank you.
Okay. So in the case of anaphora resolution, one very commonly used terminology is mention. Now mention means typically the words which are candidates for either referent expressions or referring expressions. So when we look at this sentence, John told Sally that she should come to watch him play the violin. Now here John, Sally, she, him, violin. These are some candidates for being either the referents or the referring expressions. Okay. Then in this example only, we call something as an antecedent. Okay. If it is coming, if a mention is coming before another mention. So for the word she, John and Sally both are antecedents. However, she does not refer to John. She refers to Sally. Now, this is actually a correct anaphora and this is not an anaphora. So co-referent means these two are referring to the same entity that we have, that example we have seen earlier. Then there is a concept of cluster which is equivalent with co-reference chains. So John and him, we said that okay, there is a co-reference between them and they belong to the same co-reference chain or the same co-reference cluster. Similarly, Sally and she, these two mentions are also part of another co-reference chain or a co-reference cluster. And the word violin is part of a singleton set. So in this sentence, we see three different co-reference chains or co-reference clusters. The first one is John and him. The second one will have Sally and she. And the third one will have only the word violin. And anaphora means that, as I told some time back, so the referring expression is here and the referent is here. Now the referent is appearing before the referring expression. So this is called anaphora. And if you look at the word violin, it is a mention for sure, but it does not have any anaphora. So it is a non-anaphoric mention. So if we are given a sentence, we can identify the different mentions out of it. And then from that, there could be algorithms to determine which of them refer to each other. And from that, we can build the co-reference structure. So here is one more example. Yes, Abhinav?
So what is the meaning of the antecedent that you mentioned?
So anti means before, right? So
Uh-huh.
this is an antecedent, means this one is coming, this mention is coming before she. She is a mention, Sally is a mention, Sally is coming before she. So Sally is an antecedent for she. On the other hand, John also will be an antecedent for she. But only thing is that this will be a antecedent, but not a co-reference.
Okay.
So, sir, antecedent and this anaphoric, what's the difference?
So antecedents, when it's a true co-reference, then it becomes anaphoric. So that's why Sally and she antecedent as well as anaphoric. On the other hand, John and she, John is an antecedent, but she and John are not anaphoric.
Oh, okay.
Okay, now here is one more example. Sophia Loren says she will always be grateful to Bono. The actress revealed that the U2 singer helped her come down when she became scared by a thunderstorm while traveling by a plane. So here on Sophia Loren, she, her, the actress, she. So this is one co-reference chain, and the U2 singer and Bono, this is one more co-reference chain. And this example we have seen earlier. There are more such examples. And here it's slightly different, like this stately Victorian home, the house, in the 80-year-old house, and broken dishes and shattered glass from the countertop, and starts to pack what can be salvaged from the kitchen. Now, here we're loosely defining the term co-reference because the home, the house, the 80-year-old house, they refer to the exact same entity. But when we talk about this glass or this kitchen, they're not that exact same entity, but part of this entity. So yes, so there can be co-reference chains. It depends on the definition. And yes, so where even the part of an entity can also be considered to be a co-reference. Okay, now what is anaphora? So an example is I used to have the key, but I lost it. So if you look at it, right? So it's a mention and it's a referring expression. And for that, the correct referent is key. Now this correct referent is coming before the referring expression. So it is an anaphora. On the other hand, for a cataphora, the referring expression comes before and the referent comes afterwards. So this is an example of cataphora. So this is the difference between anaphora and cataphora, the relative position of the referring and the referent expression. Which one is before, which one is after. Based on that, it is anaphora resolution or cataphora resolution. And there could be something called exosphora, which is an extra linguistic feature. So when we say things like, what is this? Suppose you are not happy with something or you see something in front of your eyes and what is this? Now the word this here is a pronoun, but it is not referring to anything which is very clearly or concretely mentioned in the text earlier. So you can think of a story where you some situation is being narrated and there is some statement like, and then John says, what is this? So for this, it is not possible to identify what is the phrase or what is the what is the part of the input text that the word this is referring to. So this is called exophora. So when we talk about anaphora resolution or identifying the coreference chains, we actually should be able to detect whether this is an exophora or it really has an antecedent or referent before. So, or if you look at the word like it might rain today, here also the word it does not have anything that it is referring to. So that is also an example of exophora. Now, the process of finding the correct antecedent for an anaphora is anaphora resolution. So this the correct antecedent is the entity to which the anaphora refers. So this is about anaphora and the task of anaphora resolution. If there are any questions at this point, you can let me know. Otherwise, we'll just proceed. So now suppose
Sir, maybe a situation where in two different sentences, the same, the referent is belonging to two different reference expressions. So what we call to the the same that word token then?
so we do not have any specific name for the co-references which are across sentences. They're still called co-references only. So here also in this example, you see like there are so many sentences and the co-reference chain is actually having entities from many of these sentences. There is no specific name attached to them.
Okay.
All right. Now consider this task that we are saying that one co-reference resolution task is where you have two mentions given. For example, key and it, and you have to say whether there is a co-reference among them. It's a positive case. On the other hand, suppose we say that, okay, for the word it and I, is there a co-reference? So it's a negative case. So given a sentence, if we have to identify all co-references, ideally what should, it's not ideally, one very brute force idea will be to take all possible spans from the text. Okay, and then from each pair of spans, you try to determine whether there is a co-reference. But it will be very computationally exhaustive, right? Or suppose you are given these two words, it and I, and you have to say whether they're co-references or not. Even before going through any sophisticated algorithm, there can be some grammatical rules which can be defined. Based on that, very quickly we can say whether they should be eliminated or not. So here are some rules. So one is number agreement. So to distinguish between singular and plural references. So John has a new car. They are red. So here the word they is plural. On the other hand, the possible mentions here, the John and new car, they are both singular. So this word they is not referring to new car. It is not referring to John as well. So we can eliminate these from our considerations. So we talked about mentions, and typically given a text, we identify the noun phrase or named entities or pronouns as mentions. So from this input, John is a noun and new car is also a noun. They is a pronoun. So these are the words or these are the phrases that we are considering. And to identify what the word pronoun they refers to, the choices are from these two sentences, new car or John. But John is singular, they is plural, new car is singular, they is plural. So they cannot be co-references. So we can eliminate them at that point only, even before we go to any sophisticated algorithm. Similarly, there could be something about gender agreement. Okay, now this is to distinguish between male, female, and non-personal genders. Now John has a new car. it is attractive, right? So here also the mention would be John, car or a new car, and it. Okay, so nouns or pronouns. Now for it, this pronoun, if we want to find what is the or what could be a possible co-reference, we can say for it, John cannot be John cannot be the correct co-reference because it is referring to a non-animate, right, and non-personal gender, and John is a male, so there is no match. So that's why it cannot be a co-reference. On the other word, it and new car both are non-living and non-personal gender, and so this might be a co-reference. So this you can retain and then you can pass it to a further sophisticated algorithm. Then there could be some examples of person and case agreement. So first person, second person, third person. There also you can have singular, plural, and based on that you can have some rules defined. So you and I have escorts. They love them. Now here for the pronoun they, is they cannot refer to you because two ways. I mean, here we do not know it can be singular or plural, but so there. But this is second person. This is this third person. So there is a person mismatch. Then this first person. This is third person. Again a past person mismatch. And this is they and this is got. So they is typically used for living things, and here it is non-living things. So these also can be eliminated. However, when we say the word them, again we see that we can apply these rules to see which are the mentioned pairs that we can eliminate from our further consideration. So number agreement is one, where we try to check whether they have the same number, like singular, plural. Gender agreement is another, where we check male, female, or non-personal genders, whether these two are agreeing. I mean, when the candidate mentions are agreeing to it. And then there could be person and case agreement. Then there come a few constraints. Okay, so there can be syntactic relationships between a referring expression and a possible antecedent noun phrase. If you look at this one, John bought himself a new car. So the word himself indicates that, I mean, the subject which I'm using here, there is a connection between these. Okay, so himself is John, but when we say John bought him a new car, this him is not John. Now this typically deals with the meaning of specific words, and there will be a handful of such words for which some rules can be created. So earlier anaphora resolution algorithms made use of these kinds of rules quite significantly. Then there is something called selectional restriction, where what are the different words to which a verb can be attached to. So when we talk about, so the way we discussed about anaphora resolution is that given two mentions, we can firstly identify the mentions and see which of the mentions are anaphoric. Right? However, it's not only the nouns or mentions that we should be dealing with. If there are any verb that can also give some clue regarding whether to consider further some mention pair or not. So this example is John parked his Acura in the garage. He had driven it around for hours. Right? Now the word it is a pronoun, so it's a mention. Then John, Acura, garage. So these are also mentions. But the word driven here says that it's a very specific verb, and we know that a garage cannot be driven. So it cannot refer to garage. So this is one selectional restriction where the verbs put on the reference. Then I picked up the book and sat in a chair. it broke. Now, book cannot break, chair can break. So the word it will refer to chair and not to book. So this again, selectional restriction. Now, if you have this kind of contextual embedding algorithm techniques and modern deep architectures where the interplay between different words and different ranges of the input sentences that can be exploited. So it might be easier to deal with these kinds of scenarios. In fact, it is done. That's why the modern deep learning based methods do well, much better on this kind of co-reference resolution task. Now, there could be something for preferences. So one is called recency. Now, entities which are introduced recently are more salient than those introduced before. So John has a legend, Bill has an escort, Mary likes to drive it. Now, this pronoun is more likely to be associated with escort than with legend because escort appeared more recently when it concerns with the pronoun it. So recency also plays an important role in giving some clue regarding what could be a possible antecedent and what could be a negative antecedent. Then there is something called grammatical role. So entities mentioned in the subject positions are more salient than those in the object position. So Bill went to the Acura dealership with John. He bought an escort. So here he is referring to Bill. So Bill is there as a subject, and typically when people analyze large pieces of text, what they saw is that these pronouns, they are often associated with nouns which are at the subject positions. So all these small linguistic cues that they identified could actually go as features in feature-based algorithms. And then if there are some repeated mentions, then chances are more that any referring expression can actually refer to that entity which is being referred to again and again. So John needed a car to get to his new job. He decided that he wanted something sporty. Bill went to the Acura dealership with him. He bought an Integra. So now this him, they refer to John, and we see that the entity John is being referred to here in the sentence many times. So when we talk about these constraints, right, number agreement, gender agreement, person case agreement, so they are kind of filters. They allow something or disallow something. On the other hand, when we have these preferences, I mean, we are not exactly saying, okay, this is allowed and this is not allowed. It gives you some degree of belief that whether these two could be a possible co-references or not. Okay. So now there are some more preferences, and these are very interesting examples. Like, say John telephoned Bill. He had lost the book in the mall. So John telephoned Bill. He had lost the book in the mall. So here he refers to John, and John criticized Bill. He had lost the book in the mall. Now the word criticized is actually a very strong word, and we know that criticism could be made if somebody is not right or doing something which is not good or not right. Now he had lost the book in the mall. Now the word lost actually aligns with that, something which was unexpected or something. So that's why this he would possibly be attached with the word Bill. Now this again comes from the verb semantics. What is the semantics of the verb lost? What is the semantics of the verb criticized? Again, if there are algorithms which can understand this semantics well, like the contextual word embedding algorithms, they can actually make these decisions better. David praised Hans because he is possibly referring to Hans, and David apologized to Hans because he. So here he will refer to David. Again, similar arguments we can give. So understanding the semantics of the verb can also be very useful in determining the anaphoric relationships. And these are very interesting examples where, so if you look at this thing, the city council denied the demonstrators a permit because they feared or they advocated violence. Now, if the sentence has the word feared, then the city council denied the demonstrators a permit because they feared violence. Okay. Now here, due to the nature of the word fear, they will refer to the city council. Again, this comes from word knowledge or semantic knowledge of the word feared. However, denied the demonstrators a permit because they advocated violence. Now here they will refer to demonstrators. Again, it is related with the verb and what kind of word knowledge that we have regarding these actions. So the task of anaphora resolution is somehow, let me summarize what we have talked so far in this lecture. So anaphora resolution determines the correct antecedent of an anaphor, and co-reference resolution identifies all the co-reference chains or all the mentions which refer to the same entity. And anaphora in case of co-reference chains, if any of the preceding entries in the co-reference chains is detected as an antecedent, the answer is considered correct. So what it means is that there's a co-reference chain that we saw earlier, right? HP Pavilion notebook, the notebook, 8, the 8. So if all preceding entries in the co-reference chains is detected as the antecedent, the answer is considered correct. So, I mean, from one word we can go to another word. Here to that also we can go to another word. So if we see that okay, these two are correct mentions, these two are correct mention pairs, these two are correct mention pairs, then we can actually, by transitivity, we can assume all of them refer to the same entity and they belong to the same co-reference chain. So this is what this sentence, any of the preceding entries in the co-reference chains is detected as the antecedent, the answer is considered correct.
Sure.
And
So, like in the last slide that you just presented on the co-reference chains, so there can be like multiple co-reference chains coming out of that one sentence in
right,
that case, right?
right,
And any of those co-reference chains, when they hold together in terms of the an anaphor and the antecedent, then that's what we call it like it is correct. Like Bono, the U2 singer is correct. So that's why this is one anaphor as well as the antecedent because the U2 singer refers to Bono actually.
right.
Okay. Got it, sir. Thank you. No, I think that was the question I had. But there
Okay,
would the co-reference chain would be there can be multiple co-references. It's not just one co-reference chain in a way.
right, there can be multiple. Okay, now and there can be different algorithms for this. There could be feature-based algorithms. There could be algorithms which do not require explicit feature identification, like the deep learning-based methods. If we talk about feature-based methods, we can use some of the clues from here to identify the features. And if there are deep learning-based algorithms, we hope that many of these things will be automatically identified by the underlying algorithm. If not, we can also try to build in small blocks to see how to enforce or how to make better use of this kind of constraints or preferences. However, that may make the model very it may make the model a bit more complex. So generic architectures which can possibly exploit all these things would possibly be better. Okay, so now if we want to design and train any co-reference resolution algorithm, we need data sets, right? So there are a few data sets which are mentioned here, like ConL 2012, where the input texts are from news articles, conversation logs, web data, magazines. There is LitBank or Literature Bank, where the inputs are from novels, and there is arrow corpus where the inputs are from dialogues and also fictions. Now suppose this is one text, and in this text there are multiple co-reference chains. So this is a dataset where these are mentioned using the tags like this. So co-reference chain ID equal to 1 and / co-reference chain ID equal to 1. So wherever you find some text inside co-reference chain ID equal to 1, all of them belong to that same co-reference chain. On the other hand, there is a second chain here where the ID is equal to 2. So Albert Roth, chairman and chief executive officer. This is an entity from co-reference chain 2. And here also we see a reference to the same person, Mr. Roth, who has been on leave from his posts. So this entire thing is marked as another entity, another expression in that same co-reference chain. There could be a third co-reference chain as well. So, and here we see a nesting structure. Jeffrey D. Lurie of GDL management, which is Eagle's crisis manager. So there is a nesting here. So this could be some traces which could be there in the data sets. And here are some example data sets. Now, so that is one very related task, and is Vinograd schema challenge. Now this is a very difficult task for automated systems to handle, and many of the modern embedding models or foundational models, they are actually evaluated on these Vinograd schema challenge. In the previous lecture, we talked about RT, textual entailment. So that is one dataset, one task, and there is one such common and widely used benchmark. So here, this schema challenge contains dataset contains multiple instances. Okay, and each instance offers two things. Firstly, a pair of sentences. They differ in only a single word or phrase. Okay, the sentences are very similar. They differ in only one single word or phrase. And secondly, a co-reference question. An example. So sentences are. So example 1 and 2, they together make one example for the schema challenge. The first sentence is, the trophy didn't fit into the suitcase because it was too large. Okay. So the question is, what was too large? The answer was trophy. It did not fit in because it was too large. The trophy was too large. The second example here is, the trophy didn't fit into the suitcase because it was too small. Only change is this large became small. Question is, what was too small? Now the answer will change. It will become the suitcase. So another example is, Bill passed the Game Boy to John because his turn was over. Now his turn was over. So here his will refer to, so whose turn was over? And that will be Bill. But if it was like Bill passed the Game Boy to John because his turn was next, and the question is whose turn was next, the answer will be John. So again, two sentences, they differ in only one word, and then there is a question, co-reference question. So, and yeah, depending on what was the word, the answer will change. Now, getting correct answers for these kinds of questions requires common sense reasoning ability. So any doubt regarding this task? There are many such examples. You can also construct your own examples for this kind of things.
So no doubt regarding this one, but for the previous slide, if you just go um, for the co-reference resolution part. So this, if we didn't have the labeled data like this, right, we could have used the self-attention to basically weight certain the word tokens and found the corresponding antecedents and the co-reference for that, right? Will that be a possible approach to proceed with that? finding out, because the self attention weights of that that word token would be higher for a particular, with respect to a particular the word under consideration.
Yeah, that could be a strong clue. How it is
Hmm.
used later could be. Yeah, that could be a strong clue. Okay, now if we talk about a feature-based algorithm for co-reference resolution, so so here again we are talking about a mention pair kind of algorithm where a word pair is given or a mention pair is given, and the task is to predict whether there is a co-reference among them. There are many features which could be there. One is, what is the distance between the sentences in which they appear? So if you remember, we had one thing called recency. So how recently they have been used. So the word it is one mention, then Mary is one mention, Scott is one mention, Bill, Legend, John. So we can identify which sentence is containing it and which sentence is containing, say, Bill, and the difference between these two sentences. So this could be one feature. Then there could be this I mark distance I pronoun, J pronoun. So mark distance is, I mean, in terms of the number of tokens, what is the difference between them? Okay. And then I pronoun, whether the first word is a pronoun or not, yes or no. J pronoun, whether the second word is a pronoun or not. Then string match, whether, I mean, what is the extent of string matching between them? Okay. So is one and a substring of another, like these kinds of things could be there. Then there could be like whether it is a definitive noun phrase, demonstrative noun phrase. Uh, this could come from the constituency structure. We talk about parsing in a future lecture. The number match, whether they have the same number agreement we talked about, right? Then gender match, whether the genders are same. So all these could be features, and then once we identify the features for I, features for J, and some common features for IJ like number match, gender match, we can define. Now that gives our input, and then we can have a classifier, which is a binary classifier, which finally says yes or no, whether there is a co-reference or not. And what people have seen that if you have some mechanism of filtering out of non-anaphoric pronouns, like the word "it might rain," "what is this," or so these kind of non-anaphoric pronouns, if you eliminate at the beginning only, the results improve, because it's really tricky to deal with those kinds of things. So this is about features. Any doubt regarding anything that we have covered so far? Okay, so what we'll do is it's around 8:50 now. So I'll check regarding the tutorial whether the persons. There'll be 2 PhD students who will be going through the tutorial. Just check whether they're here, and then we'll get started.